Okay, here is one more example of a dicarboxylic acid. So again, we're going to number in from one carboxyl group to another in a straight chain. In this case, there's only one chain, so there's only one way to number. We want to give the chlorine group, the chloral group, the lowest possible number, which means we're going to choose to number from left to right. Don't forget to number the carbons of the carboxyl group. So this is a 7-carbon chain. That's a heptane. It's got 2 carboxylic acids on it, so it's a heptane dioic acid, and there's a chlorine on carbon number 3, so it's a 3-chloro heptane dioic acid. And the last nomenclature thing that we're going to look at is cyclic dicarboxylic acids. Cyclic dicarboxylic acids are named as cycloalkane dicarboxylic acids, like cyclohexane dicarboxylic acid. And with the cyclics, we're just going to number to give the lowest possible numbers to the 2 carboxyl groups, and then secondary number of secondary importance would be to number to give the other substituents low numbers. One of the carboxyl groups will be defaulted to carbon number 1. And we want to just try to give the other group, the other carboxyl group, the lowest possible number. So 2 examples of this with stereochemistry. Here we have a 6-carbon cyclic, so this is a cyclohexane dicarboxylic acid. And we're going to choose, we want to choose one of the carboxyl groups to be on carbon number 1 of the ring. We're going to give the other one the lowest possible number, so it's a 1, 2. We have stereochemistry here that we need to figure out for both of those carbons. And this is going to be a 1, 2 cyclohexane dicarboxylic acid. You do have to identify the position of both of the carboxyl groups in the cyclic dicarboxylic acids, even though one of them has to be on carbon number 1, probably mostly because it would just sound awkward to say 2 cyclohexane dicarboxylic acid, and recognize that the set of numbers isn't implied. The second group could be over here. It could be a 1, 3, or it could be a 1, 4. Carbon number 1 is an R, and carbon number 2 has a low priority group in front, so this would be, looks like an S, but it's reversed because the low priority group's in front, so it's an R. One last nomenclature example. Not all of the cyclic dicarboxylic acids are necessarily named as such. If you have 2 carboxyl groups on a benzene ring, remember that's a phthalic acid, not named as a dicarboxylic acid. So there's a few ways that we could name this molecule. An IUPAC name for this, we could name it as a benzene dicarboxylic acid if we wanted to. To number it, we want to give the carboxyl groups the lowest possible numbers, and then give the chlorine the next lowest possible number. So the best way to number it would be like this. The other way would put the chlorine on carbon number 3. Either way, our carboxyl groups are going to be on carbons 1 and 4. So one name for this molecule would be 2-chloro-1,4-benzene dicarboxylic acid. That would work. It's going to be faster to name it as a phthalic acid. You could name it as a paraphthalic acid. One name that would work would be 2-chloro-paraphthalic acid. Or if you didn't want to use, if it makes you feel weird to mix the numbers and the para together, you could name it as a 2-chloro-1,4-phthalic acid. Any of those three names is good. And that's the end of the nomenclature section. I'm going to make sure that you get study questions written for these sections.